Hello, Integrated Math 1. Welcome to lesson E.1-1b, where we're piloting our Envision curriculum, and we're doing day 2 of solving linear equations. So we already know what you do to one side, you must do to the other. We know that we use inverse operations, right? We undo division with multiplication, we undo addition with subtraction, right? We know these things. But we're just going to start digging in a little bit more with some practical applications. So, a lab technician, we're example 3, by the way. We're on page 6 if you're not sure where we are, if you've got the book handy. If you don't have the book handy, hopefully you've at least got your notebook out to work through this. A lab technician needs 25 liters of a solution that is 15% acid per certain experiment. Fair enough, right? You don't want it too acidic, it'll eat through your stuff, but you want enough acid to do what you want it to do for your experiment. But she doesn't have a 15% acid solution. Problem. She only has a solution that is 10% acid and another solution that's 30% acid. So she knows that she should be able to mix together her 10% solution and her 30% solution to get a 15% solution, right? We know that she should be able to do that somehow. So I guess the question is, how many liters of each one, how many liters of the 10% and the 30% solutions should she mix together to get what she needs? You might want to try half and half, but of course, if we do half and half, that's too much of the 10%, it's too much of the 30%, too little of the 10%. It's just not going to work, right? So there is a mathematical way of figuring this out. So what we're going to do is we're going to write an equation relating the number of liters of acid in each solution. All right, you ready? So first of all, let's represent the total number of liters of one solution with a variable like x. All right, so let's say that for one of them, whether it's the 10% or the 30%, we can just say 10%, that's cool. But let's say that the 10% solution will be x. Awesome. Now notice we want 25 liters of that 15% solution. So if x is the liters of my 10% solution, then the total number of liters, if it's 25, means my other solution should be 25 minus x, right? Right? Because I want a total of 25. So if I subtract out my 10% solution, that'll tell me how many liters I need for my 30% solution. All right. Are you ready to write an equation? Now we're going to use words at first, and then we'll deal with variables, but we'll start by using words and a couple variables. So I want my total to be 25 liters of a 15% solution. So there it is. I want 25 liters of a 15% solution. And I'm going to add together x liters of my 10% solution and 25 minus x liters of my 30% solution. You follow? So this is how much I want in my 10% solution. And then I'll subtract that from 25 to figure out how many liters I need of my other solution. And together, that should give me 25 liters, and it should be a 15% solution. So let's distill this down just a little bit more. When we do math, we have percent, we usually like to write them as decimals, don't we? That makes it easier, right? When we write these things out as decimals. So instead of 15, I'm going to use a black pen, I think will be helpful here. So instead of 15, I can think of that as 0.15, right? Instead of 10%, I can think of that as 0.10%. And instead of 30%, I can think of that as 0.30%. I'm also noticing the word of keeps popping up. Of. Not always, but oftentimes in math, when we use the word of, that means we're multiplying. So my 15% is actually 0.15, and I'm multiplying that with my 25 liters. Same thing here. 10%, we said we're going to write that as 0.10 times x number of liters. Same thing on this last one. 30%, we said we're going to write that as 0.30 times, of usually means times, my 25 minus x. And now, this looks like an equation we can work with. I hope you also have a calculator handy because I have a feeling we're going to need that. In fact, I'm going to use it right away because I don't know what 0.15 times 25 is. So 0.15 times 25. And it looks like this becomes 3.75. I don't have to have a 0 on the end. If you leave it, it's fine. But I'm just going to rewrite that as 0.1x just to make it a little bit easier. And I'm going to go ahead and distribute that 30. We're allowed to do that. We can totally just be like 0.3 times 25, thank you calculator, is 7.5. And 0.3 times a negative x is a negative 0.3. Hooray! I'm also noticing some like terms. Do you see how I have a 0.1x and a negative 0.3x? So if I do 0.1x minus 0.3x, I get negative 0.2x. Hooray! Ooh, next step. Hang on, I didn't like that I made a little mark there. I'm going to fix that. Next step, I am going to go ahead and subtract 7.5. That's how we undo addition. We subtract, and if you do it to one side, you must do it to the other. Please be careful and make sure that you line up when you subtract. I made that mistake. I kept trying to say it was 3. It's not 3. It's 3.75 minus 7.5, and when I do that in my trusty calculator, I get negative 3.75. So easy mistake to make. Watch out. Still have my negative 0.2 over here, which is being multiplied by x. We undo multiplication with division. So I'm going to go ahead and divide both sides by that negative 0.2. If you do it to one side, you do it to the other. Negative divided by a negative gives me a positive, and I'm going to use my trusty calculator. Negative 3.75 divided by a negative 0.2 gives me a positive 18.75. Now, we found x. Let's go back and make sure that we answer the question because it wants to know how many liters of the 10% solution, how many liters of the 30% solution. So I want to make sure we get this right. We said that the 10% solution was x. So it looks like I need 18.75 liters of the 10% solution. But remember, okay, so I wrote that down. So x is the number of liters for my 10% solution. So I need 18.75 liters of the 10% solution. But remember how we got the 30% solution? Remember how the total should be 25 liters? So just off to the side, you can do a quick little 25 minus 18.75. And if we subtract that out, I'm going to do that right now. Thank you, Mr. Calculator. If I subtract that out, I get 6.25. Oh, so that's how much I need for my 30% solution. So it looks like since 25 minus x represents the liters, number of liters for our 30% acid solution, she should use 25 minus 18.75 or 6.25 liters of the 30% solution. Awesome. So if she wants 25 liters of that 15% solution, she's going to combine 18.75 liters of her 10% solution, 6.25 liters of the 30% solution. So this may seem a little crazy to you, but the truth is for people that work in labs, this is actually pretty common practice. You don't always have the exact solution concentration that you need, and sometimes you got to do a little mixing up to get it. In some cases, not often, but there are cases where nurses in emergency rooms have to do this on the fly as well. If the doctor says we need this percent solution for our IV drip, then you got to find what you've got to make that work. So typically, maybe some jobs you'll never need this, but there are several jobs where this actually is a regular practice. Something you got to do a lot. So now that you've got the feel for this and this whole set it up, carefully work your way through, make sure you answer the question, I want you to try it. Number 3 on page 6, just below the example 3 that we just did, I would like you to work this problem out. We changed it a little bit. So if a lab technician needs 30 liters of a 25% acid solution, how many liters of the 10% and the 30% acid solutions should she mix to get what she needs? go ahead, hit pause to work this out, just very similar to what you did with the last one. Hit pause to work this out. Hit play when you're ready to check your work. So very similar to last time, right? We have, apparently our lab tech still just has a 10% solution and a 30% solution, right? This is what the lab tech has in the lab. But for this experiment, probably a different experiment, we don't want 25 liters anymore. We want 30 liters. And now it's not a 15% solution. We want a 25% solution. So this means I'm going to need to do 30 times 0.25. It also means, though, let's work this out. If I say that this is X, that means that my 30% solution, because that's 30 liters, I'll need 30 minus X of that solution. So I have changed things just a little bit. So we'll do 0.25. I do see that word of, which means multiply. So we'll do 0.25 times 30. That's our 30 liter solution. We'll do 0.10. We don't do percents, we do decimals here. So 0.10 times X, and then 0.30 times 30 minus X. And now that we've got the setup, we've just got to work our way through it, right? So I use my trusty calculator because it's so useful. And I multiplied 0.25 times 30. And I also, so not only did I multiply these, I also distributed here. And again, I use my calculator. So 0.25 times 30 gives me 7.5. I just rewrote this a little bit. I didn't need the 0 on the end, so I put 0.1x. When I distributed 0.30 times 30, I got 9, and 0.30 times a negative x was a negative 0.3x. Once again, just like last time, I have like terms, 0.1x minus 0.3x. I'll get them back on. There we go. We have lights again. If I subtract my like term, 0.1x minus 0.3x, I get negative 0.2x. Just like before, undo addition with subtraction. So I'm going to minus 9 on both sides. Please make sure you line up your decimals when you subtract, or just use a calculator. You'll find you get negative 1.5, which is still equal to negative 0.2x. So our final step, this is being multiplied by x. We undo multiplication with division. So I'm going to divide both sides by a negative 0.2. That's why I got my calculator. This cancels out. That's why we did it. My pen back. So these cancel out. That's why we did it. That's why we did those two. Negative 1.5 divided by negative 0.2. I get a positive 7.5. Yeah. Let's make sure we answer the question, because we know that X is my 10% solution. So I need 7.5 liters of my 10% solution. I'm going to subtract that from 30 to find my 30% solution. So 30 minus 7.5, oh, 22.5. Great. So I need 7.5 liters of the 10% acid solution and 22.5 liters of the 30% acid solution. And now our lovely lab tech can totally make the solution they need in order to run the experiment that they need to run. Awesome. Example 4. Ooh, we're buying concert tickets. I actually did buy concert tickets just like a week or 2 ago. I got plans, people. I got plans. Example 4, 4 friends use an online code to get discounts on concert tickets. They spent $312 for the 4 tickets. What was the price of 1 ticket without the discount? Ooh. You can see we have our email from our online order. Your online order is complete. By the way, we're on page 7, if you don't know where we've wandered off to. So your order details are shown below for your reference. We've got section B, row 10, seats 13 to 16. Awesome. 4 tickets. We don't know how much each ticket was before the discount, though, right? This is the thing we're looking for. The discount, though, we got $15. Oh, we got $15 off of each ticket. So that means 4 times 15 is actually how much we got off, right? So the total was $312. Now, some of you guys are smart enough that you probably look at this and you can do, oh, I'm going to do 4 times 15. I'm going to subtract that from my 312 and then divide by 4. And that'll tell me how much each ticket was, right? But let's see if we can write an equation for that. Some of you guys know how to do this without writing an equation. That's great. But let's talk about how to set up the algebra, right? People think they don't need algebra. Let's see if we can show how useful algebra is. So we're going to write an equation to represent the situation. Now, I warn you, I'm going to start by using words in my equation, so it's going to be like kind of long and it's not going to fit on my page real well, but you'll get the idea. So I'm going to let P represent the original ticket price, right? P for price. Sounds good. So I don't know what the price is. We're just going to put a little we're going to put a little P there. I don't know what P is. So we did 4 tickets times the original ticket price minus 15, and that equals $312, right? So fine. Instead of original ticket price, let's just call it what it is. We're going to call it P. We said P was the original ticket price. So instead of original ticket price minus 15, I'm going to write in P minus 15. Now notice I'm putting parentheses here because they subtracted the ticket price. That $15 was subtracted before we multiplied by 4 for our 4 tickets. There are several things you can do now to solve this equation, which we are going to solve the equation. You have options here before you. You could distribute the 4. That would be fine if you distributed the 4 and worked it out. I'm going to take a slightly different approach. If you do want to use distributed property finished out, that's okay. It's cool. But I'm going to take a slightly different approach. I'm going to say that since this is 4 times all of this, I'm going to divide by 4. Right? You undo multiplication with division. And if you do it to one side, you do it to the other. So I'm approaching this from the perspective of, you know what if I divide both sides by 4? Because when I do that, these 4s will cancel out, which is so convenient. So now I have P minus 15. I also have a calculator, thank goodness. 312 divided by 4. Whoa, 312 divided by 4. There we go. Gives me 78. And for my last step then, I'm just going to add 15 to both sides because, of course, these will cancel out, which, again, that's why we're doing it. And 78 plus 15, boom. So it looks like the ticket price without the discount was $93. So before the discount, each ticket would have cost me 93 bucks. Awesome. Again, this wasn't the only way to solve it. It's a way to solve it. But I would like you to try out number 4 now, all right? The same 4 friends buy tickets for 2 shows on consecutive nights. Apparently, they're so excited about this show, they're going to go the next night. I may have to confess that I've done that before. There was a show in Sacramento, which I went to, and then there was another show in San Jose the following night, which I also bought tickets for and went to again. That's possible. Some of us do it, okay? It's a thing. So I can't judge too much. They use a coupon code and to get them $5 off each ticket. And they paid a total of $416 for those 8 tickets. I would like you to write and solve an equation to find the original price of the tickets. I know some of you guys can ticker around and work this out, but I want you to actually write an equation that you can then solve to find the original price of the tickets. So go ahead, hit pause to tackle this, and then hit play when you're ready to check your work. All right, so just to kick it off, I'm going to use a T for the original ticket price. If you used a P for price like we did last time, that's fine. I'm just using a different variable, no big. Now, in this case, it's not going to be T minus 15. It's now T minus 5. And I also bought 8 tickets, right? Because we're going 4 friends, 2 shows. It's all good. So we're going to do 8 times T minus 5 this time. Again, you could divide both sides by 8. That's what we did last time. But let's try the other way. I said you could distribute it, right? I'm going to distribute it. So I'm going to be like, distribute me. 8 times T is 8T. 8 times the negative 5 is negative 40. Awesome. And that means I can then add 40 on both sides. $416 plus There we go. 416 plus 40 gives me 456. And last but not least, we'll just divide both sides by 8. And so I get t equals 57. So that means the ticket price without the discount was $57. Definitely not the show I went to. The show I went to was more than $57. But I didn't want the nosebleed seats. I wanted to be closer. And maybe for the Sacramento show, I was in the 7th row. I'm just saying. It was good times. One more. You ready? This one's a little crazy. Bear with us, all right? LaTanya will walk her bike from her house to the bike shop. I've had to do that. Bike needs to be fixed. I can't ride it, but I also don't want to drive it, so I'll walk it. So LaTanya will walk her bike from her house to the bike shop, which is 1.5 miles from her house, to get the bike fixed. She expects to wait 30 minutes or so for the repair, and then she will ride her bike home. Can she be home in 1 hour? That's a good question. So I like the way we have a little map here. So she's going to walk it. She walks at about 3, and you can see I've got some information here. She's going to walk it there at 3 miles an hour, and then she's going to walk it back at 10 miles an hour. Oh my. All right. Let's write an equation. Are you ready? So her time walking plus her time at the shop plus the time biking equals our total time. We're hoping it'll be an hour. I don't know if it will be though. So you know what? I'm going to use a T for time because I don't know if we're going to make it in an hour or not, but we're going to find out. So the time walking plus the time at the shop. Now, this is where it gets a little crazy. You guys have an old formula that you probably learned in like 7th grade. It's been a while. Sometimes it's referred to as DIRT. D equals RT. Distance equals rate times time. If you divide both sides by R, you actually figure out what T is. That T equals, that cancels out, distance over our rate. So that's what I'm going to do. I want the time walking. Well, the distance walking is 1.5 miles. The rate that she walks at is 3 miles per hour. So that's what I put here. The time spent at the shop, well, that's distance. Well, we don't even need that. Time spent at the shop is 30 minutes. It's half an hour. And I'm using half an hour, not 30 minutes, because I have 3 miles per hour. So I want half an hour. I don't want minutes there. And the time biking. Well, we know time is distance divided by rate. Well, the distance is still 1.5 miles. That has not changed. Divided by our rate, which we now said is 10 miles per hour. All right, I'm going to remove all the units off of this. I use the units to help me keep everything straight, but I'm going to take the units off of this so that I can actually solve this. So I have 1.5 over 3 plus 1/2 plus 1.5 over 10 equals t to represent the situation. I'm not loving the fractions. So here's what I'm going to do. And you can see this has been here the whole time. I meant to have it fade in. I didn't. We're going to multiply everything by the least common denominator. We're going to multiply everything by the least common denominator, which in this case is 30, right? 3, 2, 10. 30 is the only number that all 3 of those numbers will go into, that all 3 of those numbers are a factor for. So fine, I'm going to multiply this by 30, I'm going to multiply this by 30, I'm going to multiply this by 30, and I even have to multiply my t by 30. At this point, you may want to grab the calculator. You guys might recall we talked in an earlier lesson when multiplying with fractions. Remember, we multiply with the top and we divide out the bottom. So 30 times 1.5, and then we divide by 3. So it looks like I get 15 here. Some of these are easier. That should say 15, shouldn't it? Oh, Miss Scott. Miss Scott. Hang on, I'm going to fix it. That should say a 15 right there, shouldn't it? That should be a 15. Better. I mean, I know I made it all disappear, but it's going to come back. There we go. So half of 30 is 15. Sorry for that. That was a mistake on my part. And then 30 times 1.5 divided by 10 gives me 4.5. There it is. So beautiful. Ooh, I can add these up. That's easy, right? 15 plus 15 is 30 plus 4.5. I've got 34.5. Awesome. Equals 30t. Need to get the t alone. So the opposite, so if it's 30 times t, we undo that with division. So I'm going to do that, divide both sides by 30. And this is why I have a calculator. 34.5 divided by 30 is 1.5. 1.15. Oh, so to walk to the bike shop, wait around to get it repaired, and then to ride her bike back is actually going to take 1.15 hours. If you're really diligent, you may have figured out that was 1 hour and 9 minutes. If you don't believe me, right? If you do 0.15 times 60, you get 9 minutes. So it's actually going to take her 1 hour and 9 minutes to get home after leaving to get her bike repaired. She's going to need a little more than an hour. Not a lot, but a little. She needs a little more than an hour. Ooh, that was complicated, but not impossible. So using everything we just talked about, using everything we just did, can you try out this next problem? Problem number 5, toward the bottom there, just underneath the example we did on page 8. LaTanya leaves her house at 12:30 p.m., bikes 12 miles an hour to Martha's house. She stays at Martha's house for 90 minutes. Both girls walk back to LaTanya's house along the same route at 2.5 miles per hour. They arrive at LaTanya's house at 3:30 p.m. How far is Martha's house from LaTanya's house? Hit pause, use the same techniques as before. It's asking for something different, that's okay. Use the same techniques as before. Hit pause to work it out. Hit play when you're ready to check your work. So again, I was looking at this from the perspective of time, right? Because time, I know the time. Time going to Martha's house plus the time that she was at Martha's house plus the time walking back equals our total time. I have a lot of information about the time. We also know from what we were doing earlier, we know that time equals distance divided by rate. So if I'm talking the time going to Martha's house, I know that the distance, actually, I don't know the distance. That's what I don't know. I don't know the distance, but I know it was the distance divided by her rate, which was 12 miles an hour, right? Plus the hour and a half she was at Martha's house. Again, it says 90 minutes, but I need it in hours to match that other stuff. So I said 1.5 hours. Plus that same distance again, which I still don't know, but it's that same distance again, which I still don't know. They walked back at 2.5 miles per hour. So that same distance, which we don't know, divided by the rate. And I do know that the total time was 3 hours because LaTanya left at 12:30 and they made it back to LaTanya's house at 3:30. So I do know it was a total time of 3 hours. Let's clean this up. Instead of distance, why don't we just put a D in there? We'll get rid of all the units now that we've made everything match up, right? But it's the same distance coming back. So notice the D is there twice. Again, I do want to multiply by the least common denominator. I had to play with this a little bit. Just a little bit. And what I did, is that the number I used? I don't think that's the number I used. I have a 30 here. It looks like I wrote that I multiplied everything by 30. Maybe I did. I multiplied everything by 30. Sorry. My lights keep going out. Go. I've got no lights. Sorry. We're going to hang out here in the dark for a little bit. So I multiplied everything by 30. You may have multiplied by a different number. That's okay. It can still work. I multiplied everything by 30. So 30 times D is, 30D. But if I divide that by 12, I got 2.5D. 30 times 1.5, again, my trusty calculator, I got 45. And 30 times D divided by 2.5, I got 12. Yeah. And of course, 3 times 30 is 90. I didn't need a calculator for that one. Ha ha ha. Ooh, I have like terms. We should combine those, right? I got like terms. 2.5 plus 12D. I should combine those for 14.5D. Yeah. Ooh, and now we can subtract 45 from both sides, right? That's how we undo addition. Whoa, we subtract. Too bad my handwriting's gone wonky. 90 minus 45 is, of course, 45. And last but never least, we need to divide everything by 14.5. Sorry, my handwriting is getting weird. It's heading toward the end of the day, people. Now, I did not get a precise answer on this. When I did this, when I did 14.5, or pardon me, when I did 45 divided by 14.5, I got like a big old decimal. So I just rounded it to 3.1, just to make it easier. So it looks like Martha's house is about 3.1 miles from Latanya's. As always, guys, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, come see me. Come talk to me. Lunchtime, office hours, during class, email me, something, and we'll get you sorted out. And I'll see you guys soon. Bye.